Y'all got sad news. It's the last video. But I should also say that I am so proud of you for making it through 7 videos, 7 different types. You've mastered them all. Now you might be confused because on the Google document, it says that there's 10 types. But really type 9 is just a word problem. And type 10 is just practice with it all. So really this is our last new thing. And it involves the calculator. Can you believe that you have just done so many things without a calculator? All of it's been without a calculator. And now we're gonna need it. All right, so get out your calculators. Notice that I have out 2, just in case you need to see it on 2 different calculators. Now first thing is I've got it, x is between 0 and 2 pi, so you gotta make sure that your calculator is in radians. So up at the top, can you see that little square? Right now my little square has a D in it, and I need to change it to be an R. The D stands for degrees, and I need it to be R for radians. So I'm gonna press my mode button. It says mode right there. None of that means anything to me, so I'm gonna press my mode button again, and now it says degree, radians, or gradient. I want radians, so I'm gonna press 2. And now it's an R, okay? Now over here, it's already an R, but in case your calculator is like this one, again, you press mode, it's the same exact thing. Make sure it's in radians. And now maybe you'll understand the little meme that I posted. Here we go. I'm gonna use my white one because I like it. Sine of x is equal to 0.3. So we don't have 0.3 on our unit circle. There's no way I can do this with my hands. I've got to use a calculator for this. But anytime you see round to the nearest hundredth, that means you're going to use a calculator. If I ask you for the exact value, then that's without a calculator. That means I want there to be some pi's involved, I want some fractions, I want what you've been doing so far, okay? But round to the nearest hundredth means calculator is going to be involved. So I've got to get the x by itself. The first thing is to pass the sign to the other side, and when I do, it becomes the inverse. So sine getting passed to the other side becomes sine inverse of 0.3. It has to go in this order, sine inverse of 0.3. This is our function, and then this is our like x value, even though we've got an x there, okay? We're gonna punch this on our calculator. It's not sine, it's sine inverse, so I gotta do shift sine, 0.3, all right? And I get 0.304, okay? I'm gonna put that down. Rounding to the nearest hundredth means 2 decimal places, so 0.30. The 4 keeps it a 0. Yes, you need to write the 0 because I'm asking you to round to the nearest hundredth, so that needs 2 decimal places, okay? Now, remember before, sine is positive, so I should have 2 solutions in the quadrants where sine is positive. Sine is positive in the first and the second quadrant. Now I've made this little key over here. If I need to get to the second quadrant, I'm going to take pi and I'm going to do minus the last solution that I just had, okay? So I'm going to keep the whole entire number in my calculator. I'm not going to press clear and then type 0.3 because this is more accurate. So I'm going to do pi, shift pi, minus the answer. Enter. And there's my other answer. So x can also be equal to 2.8, and then it rounds up to 4. Let's check ourselves. Sine of 0.3, which I rounded, is 0.29. Because I rounded it, it's going to not be exact here, but this rounds up to 0.3, so I know that that one's right. Let's try the other one. Sine of 2.84 gives me a number that also rounds up to 0.3, so I know that both are correct. So not only are we solving on our calculator, we can also check on our calculator. All right, the second one, number 2. I'm gonna try to squeeze them all on this paper. We're gonna do them all at once. Tangent of x is equal to 5. Another basic one. I don't have to do any work. I only need to pass the tangent to the other side. So x is equal to tangent inverse of 5. All right, we're gonna punch that on our calculator. I'm doing tangent inverse of 5, and that gives me 1.37. Okay? Now tangent is positive in the first and the third quadrant. So to get down to the third quadrant, I'm going to do pi plus the number that I just got. All right? So pi plus that number, shift, and I got to do my pi, plus the answer that I just got equals 4.51. So x can also be equal to 4.51. Again, I'm going to check it. Tangent of 1.37 gives me a number that rounds up to 5, and tangent of 4.51 gives me also a number that will round up to 5. 4.9 rounds up to 5, 4.87. Okay? Number 3, we're flying, y'all. Number 3, we've got sine squared of x plus 5 sine of x minus 2 is equal to 0. All right, this looks like something I should factor, right? I've got two different terms with the same trig expression, but with different exponents. So that's usually when I put it in standard form, get it equal to 0, check for GCF, try to factor. So let's try to find two numbers that multiply to be negative 2 and add to be 5. Two numbers that multiply to be negative 2 and add to be 5. No, that doesn't exist. When we can't factor, what's that we use? You can't see me, but I'm putting my fingers to my ears to try to hear you. The quadratic formula. Yes, I know you've been missing it. Some of you love the quadratic formula. So we're going to do the quadratic formula. I guess I'll write it out. Or Bhaskara, as some of you say. Quadratic formula. Now, normally we would say x is equal to something, but here my x is sort of the sine, right? So I'm going to say that sine of x is equal to, shall we all sing it together? Sine of x equals negative b plus or minus square root b squared minus 4ac all over 2a. Gorgeous. Yes. All right, 25 plus 8, negative 4 times negative 2 will be positive 8. 25 plus 8, 33. So we're going to have negative 5 plus or minus the square root of 33 over 2. Y'all don't be scared, okay? Now, when we're doing these, the goal is to not round until the last step, okay? So first thing, we're going to do negative 5. Where are you? Negative 5 plus, I'm going to do the plus version first, okay? Plus the square root of 33, enter, equals, divided by 2. Okay, and then I got to do sine inverse of that, right? Because right now this is sine of x is equal to this, and then I'm going to do sine inverse of negative 5 plus the square root of 33 over 2. And I'm going to do sine, so this can be x is equal to this, or x is equal to sine inverse of negative 5 minus the square root of 33 all over 2. I don't know if y'all can hear my dog growling. She's playing by herself. All right. I just did the divided by 2. I just did this one. So now I got to do sine inverse. So sine inverse, shift sine inverse of the answer gives us 0.38. Okay. Now, I meant to point out before I did that, so let me go back and do sine of that. Gave us that positive answer, 0.37. So sine needs to be a positive value. That only happens in the first and the second quadrant. To get to the second quadrant, I need to do pi minus, okay? So I'm going to do my sine inverse again to get back to where I was. All right, so 0.38, and then pi minus that, minus the answer. So my other answer is 2.76. Let's check it. I'm going to plug it in here, okay? So I've got sine of 0.38, sine of 0.38. I'm going to square it, plus 5 times sine of 0.38 minus 2. Negative 0.0078. That's basically 0. It's just not exactly 0 because I rounded this. That's why the exact solutions are so much better, like pi over 2 and 3 pi over 4. That's why those solutions are better, because they are exact. These are estimates. They are rounded. So now let's try 2.76. So sine of 2.76 squared plus 5 times the sine of 2.76 minus 2, 0.00067, blah, blah, blah. Basically 0. Essentially 0. If we round it, we would get 0. So those are our two solutions. Okay? Now let's come over here. Let's do negative 5 minus square root 33. Divide that by 2. Okay, let's take a moment. Let's pause. We got negative 5.3. Remember we talked about how sine oscillates between positive 1 and negative 1. It's never going to be equal to something bigger than positive 1 or smaller than negative 1. But here we got negative 5. That definitely is smaller than negative 1. Sine of x cannot be equal to something smaller than negative 1. So hopefully you saw this, took note, and thought, well, I'm not going to have a solution here. But maybe you didn't. Let's see what happens. We're going to do sine inverse of that answer, and we get a math error. Not possible. So x, well, it's just not possible. Not possible. Which means we have just these two solutions, and we're done. Okay, I had planned on doing one other one, but I think you'll be able to take it from there. Call me over if you have any questions. Y'all, it's been an honor and a pleasure and a joy. I hope you've enjoyed the videos. We might do some more in the future, but that's the end for this unit. For your next ongoing, that's the end of the videos. May you watch them again and again